Every electric vehicle begins with raw materials extracted from the earth.
Copper provides the electrical pathways needed for power transmission.
Graphite plays a key role in modern battery chemistry.
Lithium is a critical element used in electric vehicle battery systems.
Each raw material is identified and secured for controlled transport.
Lightweight aluminum is essential for vehicle structure and efficiency. Materials are prepared for shipment to manufacturing facilities. Raw materials now begin their journey toward vehicle production.
This journey leads directly to the electric vehicle factory. Processed materials move under controlled logistics toward the electric vehicle manufacturing facility.
Transportation routes are planned to maintain timing, safety, and material integrity.
Every shipment enters through secured access points for tracking and verification.
Incoming materials are verified against shipment records before handling.
Loading docks are prepared to receive materials safely and efficiently.
Materials are unloaded carefully to prevent damage or contamination.
Controlled environments preserve material quality during transfer. Automated systems take over to guide materials into production flow. Transport concludes as raw materials officially enter the manufacturing facility. Materials are routed precisely to their designated production zones.
Raw materials now cross from logistics into the heart of vehicle manufacturing.
Battery components are directed towards specialized preparation areas.
Electronic materials are staged under controlled handling conditions.
Structural materials move toward body manufacturing operations.
Initial inspections confirm material readiness before processing.
Verified materials rejoin the main production flow.
Oversight begins early to maintain consistent manufacturing standards.
Factory entry concludes as materials prepare for initial processing. Initial processing begins by separating materials for dedicated cleaning procedures.
Structural metals are cleaned to remove surface contaminants before shaping.
Drying stabilizes metal surfaces for precise manufacturing.
Copper is cleaned carefully to preserve electrical conductivity. Sensitive battery materials require controlled, contamination-free cleaning.
Screening ensures consistent particle size for battery performance. Human inspection verifies the effectiveness of automated cleaning.
Identification ensures traceability throughout production.
Clean materials now advance toward core manufacturing operations.
Initial cleaning concludes as core processing is ready to begin.
Core processing begins as materials are transformed into functional vehicle components.
Aluminum sheets are stamped into structural panels that shape the vehicle body. Trimming refines body panels to exact design specifications. Copper windings form the core of electric drive motors. Motor housings are machined to support efficient power delivery. Battery chemistry is prepared through carefully controlled material mixing.
Electrodes are coated to store and release electrical energy efficiently.
Controlled drying stabilizes battery electrodes for reliable performance.
Core components are synchronized in preparation for full vehicle assembly. Core processing concludes as components advance toward vehicle assembly. Body panels are welded to form the rigid structure of the vehicle.
Precision welding ensures structural strength and safety.
Automated inspection verifies assembly accuracy before drivetrain installation. Electric motors are installed to deliver efficient propulsion. High-capacity battery packs are prepared for integration. Battery systems are secured to power the vehicle safely and reliably. Power and thermal systems are connected to support performance and safety. The vehicle takes shape as suspension and wheels are installed.
Main assembly concludes as vehicles prepare for advanced automated systems.
Vehicles now move into advanced automation and system integration.
Advanced sensors are calibrated to ensure accurate perception.
Automated testing simulates real-world operating conditions.
Electronic systems are installed to control every vehicle function. Digital interfaces bring intelligence and connectivity to the vehicle.
Core vehicle software is uploaded and verified.
Control systems are tested for safety and responsiveness. Battery systems are digitally verified for reliability.
Final automation checks confirm system readiness.
Automation completes as vehicles move toward precision finishing. The vehicle now enters the precision interior finishing stage. Seating systems are installed with millimeter accuracy. Each seat is secured and electronically connected.
Control surfaces are finalized inside the cabin.
Glass components are installed to seal and protect the interior. Interior finishes are visually checked for precision.
The vehicle now enters the quality control inspection stage.
Exterior surfaces are carefully examined for consistency.
Electronic systems are tested for proper operation.
Drivetrain systems are tested under simulated driving conditions.
Braking performance is measured for safety standards.
Sealing integrity is tested against water exposure.
Final diagnostics verify full vehicle readiness.
Quality-approved vehicles move toward final delivery preparation.
Finished vehicles now enter the storage and dispatch stage.
Each vehicle is positioned for organized storage.
Shipping information is verified and recorded.
Vehicles are transferred toward outbound logistics zones.
Transport systems are prepared for final shipment. Each vehicle is secured for long-distance delivery.
Final inspections confirm readiness for delivery.
Completed vehicles leave the factory to reach customers.